Hey everyone, and welcome to the EZ MIDI 2 video tutorial series. For the fourth video, we're going to use the EZ MIDI web editor for customizations. Before using the web editor, we'll take a minute to plan which options to use. We're going to prototype a resonant filter effect in the next video, so let's take a look at the schematic. This filter is loosely based on the Oberheim VCF, using an LM13700 operational transconductance amplifier. Instead of using potentiometers, it uses voltage control, making it well suited for EZ MIDI. This section converts the control voltage input to an exponential response. This section controls the filter resonance via feedback, also controlled by control voltage. For demonstration purposes, I'm going to replace this with a digital pot. So now that we have a view of what's going on inside, let's imagine what a finished pedal might look like. It's 6 knobs and LFO based with switches for bypass and tap tempo. EZ MIDI allows up to 8 control pot inputs, 6 of which are assignable. For LFO-based designs, pot 7 selects the LFO shape and pot 8 selects presets. Pot 3 and pot 4 can be assigned to control the LFO depth and manual output. Alternatively, you can have the LFO output at full amplitude and manipulate it with digital pots. For the sake of keeping this prototype simple, I'm going to use the first option. So here's my plan for knob assignments. And we're ready to move on to the web editor. This will require a computer with a MIDI interface. You'll need to have the circuit from the PDF breadboarded, or you'll need an EZ MIDI programmer board. After getting MIDI connected, open the web editor. You'll find the link in the description. Once you have EZ MIDI connected, select the MIDI output. There are a few tabs on the left. We'll be starting in the main tab. Select the bypass type, either control voltage or relay bypass. Since I'm using the EZ MIDI programmer board, I'm choosing control voltage as it's already integrated into the board. For LFO-based designs, you can select warp or non-warp LFOs. I'm going to use the non-warp LFOs. The control voltage array option is more suited for multi-channel overdrive effects. At the time of recording this video, the other options for delay effects are not yet implemented but are coming soon. Pot 7 selection quantity lets you assign how many different LFOs Pot 7 can select. I'm going with the maximum of 11. For the Pot 3 and 4 option, I want to use Pot 3 and 4 to directly control the LFO depth and manual offset. I'm selecting yes. Leaving the LFO rate set to Pot 6. I'm using the non-warp LFOs, so this setting won't matter. I'll just leave it at the default. LFO smoothing will round out the hard corners of LFOs. Like if you use a square wave LFO with some effects designs, this will cause an audible clicking or popping noise. I'm leaving it at 64, the default setting. For less smoothing, use a smaller number. For maximum smoothing, set it to 127. After finishing your selections, click Send Tab MIDI Data. This sends all the choices from this tab to EZ MIDI. After MIDI data is sent, the OLED display will update. You'd use the Control Voltage Array tab if you chose Control Voltage Array for the operation type. Since we're using an LFO-based design, we can skip this page. On the right side of the screen, you can see a list of non-warp LFOs. You can find this list on our website. On the left, I'm assigning LFOs in the editor. Click at the bottom to send MIDI data. For the Control Voltage Output tab, we'll assign our outputs. By default, 7 is our LFO output. Since our resonance control uses a digital pot, I don't need to use any of the other outputs, so I'm clicking Send Tab MIDI Data. Now for the Digital Pots tab. First, I should make a quick note that you can use EZ MIDI without digital pots at all. You can do everything through control voltage, like in our original schematic, but this would miss the opportunity to demonstrate how to assign digital pots to a control. They are connected via an SPI daisy chain. So what does that mean to you? EZ MIDI supports up to 3 dual digital pots for a total of 6 controls. The first IC connected will always be digital pots 1 and 2. We only need 1 digital pot, so if you are following this tutorial, you'll want to assign digital pot 1 or 2. Whatever digital pots aren't used can be omitted from your schematic. Once you're done, click Send Tab MIDI Data. If you think you've made mistakes, you can always go back to previous tabs and resend the MIDI data. Once all controls are assigned, you'll press Switch 1 to finalize customization. After pressing the switch, the display will update and show current parameters. You can use this for testing, either with an effect or with LEDs. For full functionality, you're going to want to change the EEPROM position. Power down EZ MIDI. Move the EEPROM from EEPROM 3 to EEPROM 1. If you have the breadboard set up from the PDF, you can test that your controls are working with the LEDs. In the next video, we'll prototype the filter effect. If you have any questions, drop them in the comments below. Don't forget to like and subscribe. Thanks for watching, and I'll see you in the next one.